Okay, so let me build it. Okay, let me debug. So let me come to this watch. I'll go inside this one, right? So I'll go inside this one. So you do this and you change the value to B. Okay, so it means this char 1 earlier it was 66, now it become 65, now it becomes 66, right? So now we will go inside this one. Okay, we are passing the B actually. Okay, sorry, actually I didn't go inside. So this one, okay, let me do it again. So you will go inside this one and change the value A to 65 to 66. So now let me go inside this one. So it is now 66, right? It's a B. Now what happens is this 66 become 67 now. That becomes C. So it comes out. If you see the values, this got changed. It got changed here. So it's because we are passing by reference. You know, like in Java, you have pass by value and pass by reference, right? Pass by value means you pass the actual value, it will work on the data will not get modified actually. When we pass by reference, data gets modified. So that's what it happens. I told you in one of the slide what is the process behind that pass by reference. So that this function I have written here. So what happens is it's a reference. So I told you at that time, just recollect what I said. It will create one link, right? I said it will create one link. It won't create a character variable. It will, since this is a reference, it will create a link, and that link will be pointing to, that link will be pointing to so I am explaining in the case of this pass by reference. So I will just copy this one. So imagine like we are calling this one after this one, after this first function, increment function, we are calling here. So I am calling it here. So the first function when it calls, the process is something like this, using the pointer, right? First it will create a copy, it will write the value of this address, and then by dereferencing we just modify the value of this one from 65 to 66, right? So earlier I said even the same thing happens for reference when you pass by reference. So it will be pointing to here, but I didn't tell you like what goes on behind the scene actually. So I said like some reference gets created here, and when I try to change the value, this one, this 66 becomes 67, right? So you remember I said it that way. So 66 becomes 67. Okay. So by it was 65, by passing it to this function, increment function, it becomes 66. It is not plus actually. So it is 67. Okay. So I said and then we are calling this function, and you remember I said it will create one reference and it will be pointing to this variable, and it will instead of path by value it will be path by reference. So it will be working on this variable, not on this variable. So in your code, where is it? In your code, what you do, this one here, behind the scene, compiler will change it to this one. So this particular function that you have written is visible to you. Okay. Same thing happens for this function also. Compiler will change this function to this one internally. So it means path by reference nothing but a pointer actually. It works with a pointer internally, but I said pointer in this case. So actually it is a pointer, but it won't tell you like it is a pointer. So just it is hiding actually. But in reality, this is what is going on behind the scene. So compiler will write it for you actually. These things will change it. So you just keep this in mind actually. So this is what about pointers, fine, right? So I said about the reference, path by reference, I told you I will give an explanation when I teach you about the pointer, right? What goes on behind the scene, what is happening when you pass by reference. This is what, nothing but it's passed by pointer only actually. This is what it happens. So clear, right? So okay. One more thing there actually. Okay. So I'll just finish this. Okay, I'll just finish this. Okay, again pointer to this one will cover next week. This one will cover next week. So now pointer to a structure. Actually, structure is nothing but a user-defined type, right? So we'll see that one actually. That is one type of special thing also. Okay. So you got this point, right? So this is what it happens behind this thing. That's what I was explaining. Okay. Now we know pointer to a variable actually. Just we'll see pointer to a structure. So what happens is we'll define one structure. This is becoming a little complex. I will create one more project, right? Something struct pointer, structor class pointer. Okay. All platform. Okay, let's define one structure. you can use anything. I will use class. Okay, you can also use struct class some class or student. Take student. Okay, and we'll declare as public. We'll care it's a member variable, so m underscore ch grade then no okay, you will change it here, wk underscore okay, in m underscore. In CAD project you will not be able, you will not see such notation m underscore, so you will have a difficult time to see like whether it's a member or something else. But I'll tell you, but you have to guess. Most of the time you will guess, and sometimes this notation will not be, whether it's a character or something else. For example, they have a variable, member variable called fn. So can you guess what it is? You don't know actually. It's a string actually. It's a file name. So, but there are many other variables, something like this, which we have to go to the structure and see what is the structure. So, okay, you don't follow that one. Okay, you just keep the follow the notations, please. Okay, int n marks. This is enough actually. We'll create a data for this. stu1. Okay. And we'll create a pointer. stu pointer. P the stu1. And you can initialize it with address of stu1. That's it. And later on you can just at the end you have to change it to null. So before usage, what you have to do, you have to check if this is not null. Okay. Okay, we will write here. So you will access this structure with, how do you access a member variable? Object dot. Okay, you use dot. Okay, so you can use, this is what we like sometime back we studied, I think. Okay, using pointer. Okay, you have a pointer, so I'll just comment this one. Grade or something. It's E grade. Okay, I'll just comment this. So I'll tell you how to, two ways are there, two ways to access using pointer. Okay, now and consider this is just a type, but a pointer, but just a type. Okay, user dependent. How do you get the value which is pointed to by this pointer?
Star
Dereference. Exactly. Dereferencing. We'll put star PSTU1. We'll put a bracket actually. Okay. No, we are accessing, by dereferring we are accessing the actual student object. Okay. Now how do you access the member variable?
Dot.
Right, you're following? Dot, that's it. Same as this one, except in the pointer case you just dereference and point. Okay, this is more equal to 100. Okay, there's one more way. Which is not there in Java, I think, right? So you don't have to dereference. You can use an arrow. That's it. 200. Both are same. This is the actual object. This is the pointer to an object, and this is actually pointed to an object using the send. We call this as arrow or send operator. You can send operator or arrow. You can use any name. These are the two ways are there actually. So one more thing. This is a class, right? You can override just an additional point. You can override this star dot operator. You know, like you can override plus plus, right? You override, Sujita, override plus plus or override plus sign, or you can do override means within a class. We call like this. Okay. In Java we don't know. We can override all these operators. In this case, you can also override this one also. You can also override this operator. These are operators. So this operator used here. This operator is used here. Okay. So you can override. Means you can have you want to manipulate something more on this particular member variable. You can write your override an operator, and you can send. So keep it in mind actually. Pointers is just a normal variable. Okay. So what all you know about variables that applies to it has an address, it has a value also. Additionally, you can dereference. When you assign an address to a pointer variable, you call referencing. When you get the value of the place where it is pointing to, we call dereference star. That's the addition thing. And with respect to structure, we use this kind. Dereference first the pointer. Actually, this is an object. This and this student stu1 and this are same. Star p stu1 are same. That's why we can use star dot, or you can use send operator. With so this and many other things are there which you can. They will explain very clearly and neatly in that book. Actually, it will explain properly. Okay. Anything else? Referencing dereference pointer signature, assigning pointer to variable, movement structure plus. Okay. So far what we have seen is existing variable only we assigned it using the address referencing. Okay. We didn't allocate in heap actually. We didn't allocate in heap and then assign. That next week I will cover. Any doubt you got? Okay, let me add one more thing. Suppose you have an array. Okay, that's one more thing. I have an array of let's keep it simple, int an array of mass of 10 student, okay, and then you initialize it. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Did I tell you one thing? Suppose you are writing a program like this without, means it's not neat actually, right? If you normally you tend to write, everybody tends to do like this. You won't leave any space or anything. I told about to Kishore, I think I told to Sujita also. So you just, it is not neat, right? So everything is clubbed together. So see that your program is neat. So finally what you have to, like, in order to arrange it properly, you just put one semicolon with it. Remove the semicolon and again it will align itself. So auto align is there. So it will be okay. Internally it didn't align. So maybe that one you yourself can do it. Okay. How do you, okay, let's keep the structure separate actually. So here, so how do you access the value of an array? Suppose I want to print WCAO, print the marks of the first student.
Zero, not zero.
It will be completely an array, right?
Array marked zero.
Okay. Oh, 0. So any element you can access with that index, right? So fifth person will be like, so it starts with 0 actually. So first person is 0. Okay, you know that thing. So this is the sixth person actually. So okay. I want to get the address of this fifth person. Ampersand, you just add ampersand. But see that you just put an ampersand bracket, that board mass, right? Something equal from this, so that the priority will be this. Sorry, actually it should not be like this. It should be, you just remove this one. You just remove. It means like you get the address of the fifth element. Maybe you can see this one and this one. So what happens is, let's build and see. It failed actually. No merchant token. Okay. See what happens. It prints the address. So it is also same as, it just without bracket also you can do it. So okay. So I want to print the address of the first person marked 0. Okay. Let's print this. Okay, it printed this F888, and So let me draw the diagram for this one. What is this? I didn't prepare, but just trying to explain it. Or something like this. And let's forget this one. So there are 10 arrays, that means 10 elements are there, right, of int. So maybe I will draw here like this. So something like this. So this has got an address. Maybe 0x00123 4. Okay. And it is compiler knows this by n array marks. Okay, and has that got the value also. So 10, 20, something like that. Okay, 30. Okay, so in order to get the address of the 0 element, it will print here, like this statement will print 0x 00123 okay, so it will print this value because this is the address, starting address. So I don't know how to explain you. I'm trying to explain you, but so just see, this is a one variable array, right? Array. When you will remove this ampersand, so when you do this, you are trying to get the element of the first person, like zero location. It is a kind of dereference actually. So I can also write like this also. We can that is star plus 0. This will be in more detail, it will be explained in more detail in the books actually. So you are dereferencing it. Maybe I will try to print. Let's see, both are 10. So 60% plus 6. I will put a plus here, a space here. 70, okay. So I told you how to get the address of the 60% ampersand, right? Okay, I will copy this whole thing again. Okay, I said like either you can give within bracket or within outside. So first thing you will get address of this person. Okay, so okay, let me comment this one. So, let me compile this. Let me run this. So address is F820, right? Okay. So how to get the address through using this method?
Dereferencing operator. Removing dereferencing operator.
Yes, that's what I'm coming to. So in normal way, you know that this is same as this one. Okay, this is same as this one. So when you add ampersand, you have to add an ampersand, right? But thing is, you are referencing and dereferencing. When you add one and subtract one, what will happen? Zero. Nothing. So it gets cancelled out. It cancels out. So let's see what happens now. It prints the same value. So I'll now the first person 0 0. This is the address of the first person, same value. 0 is nothing. You can just, without adding itself, you can remove the bracket. So same value. So finally what I am saying is, and this is an array, right? But it acts as a pointer. That's the point I am trying to tell you. An array and pointers are same. I will explain more when declaring that malloc and all these things. So keep that in mind. Array can be treated as pointer, pointer can be treated as array. So you got it? You understood? So, but I want to explain more, but it will be too much for you. Okay. So I will come next week actually. So maybe I will stop it from here. Sunday you got that one, right? You understood, right? Okay. You have any other doubts? What you said actually, you referencing and dereferencing, you said something.
Removing dereferencing operator.
Yeah, that's what. I just only explained, it will get cancelled. Okay. What you said is correct actually. So I'll just close it. I'll close it, right?